Can a website detect when you are using Selenium with chromedriver? I've been testing out Selenium with chromedriver and I noticed that some pages can detect that you're using Selenium even though there's no automation at all. Even when I'm just browsing manually just using Chrome through Selenium and Zephyr, I often get a page saying that suspicious activity was detected. I've checked my user agent and my browser fingerprint, and they are all exactly identical to the normal Chrome browser. When I browse to these sites in normal Chrome, everything works fine, but the moment I use Selenium I'm detected. In theory, chromedriver and Chrome should look literally exactly the same to any web server, but somehow they can detect it. If you want some test code, try out this. If you browse around StubHub, you'll get redirected and blocked within 1 or 2 requests. I've been investigating this and I can't figure out how they can tell that a user is using Selenium. How do they do it? I installed the Selenium IDE plugin in Firefox and I got banned when I went to stubhub.com in the normal Firefox browser with only the additional plugin. When I use Fiddler to view the HTTP requests being sent back and forth, I've noticed that the fake browser's requests often have no cache in the response header. Results like this: is there a way to detect that I'm in a Selenium WebDriver page from JavaScript suggest that there should be no way to detect when you are using a WebDriver. But this evidence suggests otherwise. The site uploads a fingerprint to their servers, but I checked and the fingerprint of Selenium is identical to the fingerprint when using Chrome. This is one of the fingerprint payloads that they send to their servers. It's identical in Selenium and in Chrome. VPNs work for a single use, but they get detected after I load the first page. Clearly some JavaScript is being run to detect Selenium.
Replacing cdc_string. You can use Vim or Perl to replace the cdc_string in chromedriver. See the answer by @Chris Eelmar to learn more about that string and how it's a detection point. Using Vim or Perl prevents you from having to recompile source code or use a hex editor. Make sure to make a copy of the original chromedriver before attempting to edit it. Our goal is to alter the cdc_string, which looks something like $cdc_lazutopfchumukful. The methods below were tested on chromedriver version 2.41.578,706. Using Vim. After running the line above, you'll probably see a bunch of gibberish. Do the following. Replace all instances of cdc_ with dog_ by typing $s/cdc_/dog_/g. Dog_ is just an example. You can choose anything as long as it has the same amount of characters as the search string, for example, cdc_, otherwise the chromedriver will fail. To save the changes and quit, type $WQ and press return. If you need to quit without saving changes, type $Q and press return. Using Perl. The line below replaces all cdc_ occurrences with dog_. Credit to Vic CWIU. Make sure that the replacement string, for example, dog_, has the same number of characters as the search string, for example, cdc_, otherwise the chromedriver will fail. Wrapping up. To verify that all occurrences of CDC_ were replaced. If no output was returned, the replacement was successful. Go to the altered chromedriver and double-click on it. A terminal window should open up. If you don't see killed in the output, you've successfully altered the driver. Make sure that the name of the altered chromedriver binary is chromedriver, and that the original binary is either moved from its original location or renamed. My experience with this method. I was previously being detected on a website while trying to log in, but after replacing CDC_ with an equal-sized string, I was able to log in. Like others have said though, if you've already been detected, you might get blocked for a plethora of other reasons even after using this method. So you may have to try accessing the site that was detecting you using a VPN, different network, etc.
Basically, the way the Selenium detection works is that they test for predefined JavaScript variables which appear when running with Selenium. The bot detection scripts usually look anything containing word Selenium, WebDriver and any of the variables, on window object, and also document variables called $CDC_ and $WDC_. Of course, all of this depends on which browser you are on. All the different browsers expose different things. For me, I used Chrome, so all that I had to do was to ensure that $CDC_ didn't exist anymore as a document variable, and voila, download chromedriver source code, modify chromedriver and recompile $CDC_ under different name. This is the function I modified in chromedriver. File call _function.js. Note the comment. All I did I turned $CDC_ to random blah blah _. Here is pseudocode which demonstrates some of the techniques that bot networks might use. According to user SCX, it is also possible to simply open chromedriver.exe in a hex editor, and just do the replacement manually, without actually doing any compiling.
As we've already figured out in the question and the posted answers, there is an anti-web scraping and a bot detection service called Distill Networks in play here. And, according to the company's CEO's interview, even though they can create new bots, we figured out a way to identify Selenium via tool they're using, so we're blocking Selenium no matter how many times they iterate on that bot. We're doing that now with Python and a lot of different technologies. Once we see a pattern emerge from one type of bot, then we work to reverse engineer the technology they use and identify it as malicious. It'll take time and additional challenges to understand how exactly they are detecting Selenium, but what can we say for sure at the moment? It's not related to the actions you take with Selenium. Once you navigate to the site, you get immediately detected and banned. I've tried to add artificial random delays between actions, take a pause after the page is loaded, nothing helped. It's not about browser fingerprint either. I tried it in multiple browsers with clean profiles and not incognito modes, but nothing helped. Since, according to the hint in the interview, this was reverse engineering, I suspect this is done with some JavaScript code being executed in the browser revealing that this is a browser automated via Selenium WebDriver. I decided to post it as an answer, since clearly, can a website detect when you are using Selenium with chromedriver? Yes. Also, I haven't experimented with older Selenium and older browser versions. In theory, there could be something implemented/added to Selenium at a certain point that Distill Network's bot detector currently relies on. Then, if this is the case, we might detect, let's detect the detector, at what point/version a relevant change was made, look into changelog and change sets, and, maybe, this could give us more information on where to look and what is it they use to detect a WebDriver powered browser. It's just a theory that needs to be tested.
A lot have been analyzed and discussed about a website being detected being driven by Selenium-controlled chromedriver. Here are my 2 cents. According to the article, browser detection using the user agent serving different web pages or services to different browsers is usually not among the best of ideas. The web is meant to be accessible to everyone, regardless of which browser or device a user is using. There are best practices outlined to develop a website to progressively enhance itself based on the feature availability rather than by targeting specific browsers. However, browsers and standards are not perfect, and there are still some edge cases where some websites still detects the browser, and if the browser is driven by Selenium-controlled WebDriver. Browsers can be detected through different ways, and some commonly used mechanisms are as follows. Implementing captcha, reCAPTCHA to detect the automatic bots. You can find a relevant detailed discussion in How Does reCAPTCHA 3 Know I'm Using Selenium/chromedriver? Detecting the term headless Chrome within headless Chrome user agent. You can find a relevant detailed discussion in Access Denied page with headless Chrome on Linux while headed Chrome works on Windows using Selenium through Python. Using Bot Management Service from Distill Networks, you can find a relevant detailed discussion in Unable to use Selenium to automate Chase site login using Bot Manager Service from Akamai. You can find a relevant detailed discussion in Dynamic Dropdown doesn't populate with auto-suggestions on this URL when values are passed using Selenium and Python using Bot Protection Service from Datadome. You can find a relevant detailed discussion in website using Datadome gets captcha blocked while scraping using Selenium and Python. However, using the user agent to detect the browser looks simple, but doing it well is in fact a bit tougher. Note, at this point it's worth to mention that it's very rarely a good idea to use user agent sniffing. There are always better and more broadly compatible ways to address a certain issue. Considerations for browser detection. The idea behind detecting the browser can be either of the following. Trying to work around a specific bug in some specific variant or specific version of a web browser, trying to check for the existence of a specific feature that some browsers don't yet support, trying to provide different HTML depending on which browser is being used. Alternative of browser detection through user agents. Some of the alternatives of browser detection are as follows. Implementing a test to detect how the browser implements the API of a feature and determine how to use it from that. An example was Chrome unflagged experimental look behind support in regular expressions. Adapting the design technique of progressive enhancement, which would involve developing a website in layers, using a bottom-up approach, starting with a simpler layer and improving the capabilities of the site in successive layers, each using more features. Adapting the top-down approach of graceful degradation, in which we build the best possible site using all the features we want and then tweak it to make it work on older browsers. Solution. To prevent the Selenium-driven WebDriver from getting detected, a niche approach would include either/all of the below-mentioned approaches. Rotating the user agent in every execution of your test suite using fake_user agent module as follows. You can find a relevant detailed discussion in way to change Google Chrome user agent in Selenium. Rotating the user agent in each of your tests using network.setUser override through execute_cdp_cmd as follows. You can find a relevant detailed discussion in how to change the user agent using Selenium and Python. Changing the property value of Navigator for WebDriver to undefined as follows. You can find a relevant detailed discussion in Selenium WebDriver, modifying Navigator.WebDriver flag to prevent Selenium detection, changing the values of Navigator.plugins, Navigator.languages, WebGL, hairline feature, missing image, etc. You can find a relevant detailed discussion in is there a version of Selenium WebDriver that is not detectable? Changing the conventional viewport. You can find a relevant detailed discussion in how to bypass Google Capture with Selenium and Python. Dealing with reCAPTCHA. While dealing with toCAPTCHA and reCAPTCHA v3, rather clicking on checkbox associated to the text "I'm not a robot," it may be easier to get authenticated extracting and using the data site key. You can find a relevant detailed discussion in how to identify the 32-bit data site key of reCAPTCHA v2 to obtain a valid response programmatically using Selenium and Python requests. TL Drive. You can find a cutting-edge solution to evade WebDriver detection in Selenium Stealth, a proven way to evade WebDriver detection.